Hello boys and girls, Mr. Giomini. Wanted to come to you with a video. I have about 6 problems here that deal with solving one-step equations with rational numbers. Now, in class we've done a lot of things with solving one-step equations, even some two-step equations when we had whole numbers. And I'm not even calling them integers because we weren't dealing with positive and negatives. We were dealing with whole numbers. Now we're taking and expanding our foundation of dealing with whole number, one-step integers, and tying in rational numbers. Now again, always, this is kind of sound repetitive, we need to be fluent with our addition, subtraction, multiplication, division of whole numbers, decimals, fractions, and mixed numbers. And this is really going to test our skill set here. So taking a look at our first equation, we have s plus 1/4 equals 12 1/2. I see the variable s here. I need to isolate it. I'm going to keep it on this side of the equation, on the left side of the equation. There is no s's to combine it with on the right side. What this tells me now is I need to get rid of the 1/4. Now to get rid of 1/4, I need to do the inverse of adding it. So we're going to use the subtraction property of equality. Whatever I do to one side of the equation, I must do to the other side to keep them balanced, to keep them equal. So I'm going to now subtract 1/4 from both sides of this equation. Now there's a couple ways to approach subtracting mixed numbers with a fraction. Obviously this cancels out. That's why I've subtracted from both sides. It leaves me with the s, which is what I'm excited about. I want to solve for s. It's unknown. Now I'm going to do some math down here. We have 12 1/2 minus 1/4. And we are subtracting. First thing we're tying into is look at this denominator. We have a half here. We have a 1/4 here. Those denominators do not talk to each other. We need to make those denominators common. We're going to do this by finding their least common multiple of the denominators. So we have 2 and 4. Where their least common denominator, or least common multiple, is 4. Well, this is already in 4, so that's great. So that's just going to stay 1/4. I go over here, the whole number stays the same. The denominator now becomes that 4. And we ask ourselves, what do we multiply 2 times what gives me 4? Well, that's 2. And if I have a half, that's the same as having 2/4. We are now going to subtract 12 2/4 minus 1/4. Well, 2 minus 1 gives me 1. That is 1/4. 12 minus nothing gives me 12. So my answer is 12 1/4. And again, if you are fluent and understand fractions, you would know that if I took 1/4 away from a half, I have 1/4. So there is my answer. And if I substitute that back in, we have 12 1/4 plus 1/4 gives me 12 2/4, which is the same as 12 1/2. So I would agree with this answer. That is a check, yes. Let's go on to this next one over here. We have 2 2/3 plus y equals 4 1/4. Now, I have two terms here. I have the 2 2/3. I have the y. There is no y on the other side. There's only one term over here, 4 1/4. So I'm not going to bring any y's over to the left or bring them over to the right. So this y is going to stay right here. In order to isolate this y, I need to get rid of this term of the 2 2/3. Well, this is a positive 2 2/3. So to undo that positive, I do the subtraction property of equality. I'm going to subtract 2 2/3 from both sides of this equation. Now I'll make this a little neater. This cancels out, so all I'm left with on this right side of the the left side, the left side of the equation is the variable y, which I am happy with. Equals. Now on the right side of the equation, I have 4 1/4. And I'm going to write this one going horizontally, the last one I did vertically, minus 2 2/3. Now, first thing I notice is the denominators are not the same. We have something broken into fourths here, something broken into thirds here. I need to find the least common multiple of those denominators. So for right now, the whole numbers stay the same. 4 minus 2. My new denominator, the least common multiple of 4 and 3 is 12. And this goes back to our work from topic 3. Now to find the new numerators, if we have something in 12ths, they were in fourths, we multiplied by 3, so we must do the same to the numerator. 1 times 3 gives me 3. This is 12ths. We multiplied 3 by 4. Multiply the 2 by 4, we get 8. Now the next thing I notice is, whoa, I can't take 8 from 3. I now need to, and I know many of you like to do this, so I'll use this algorithm. You like to convert this into an improper fraction. So I have 12ths. I have 4 12ths. So if I have 4 whole 12ths, that gives me 48 plus the 3 left over. 48 plus the 3 gives me, we now have 51 12ths. Minus, we have something in the 12ths. We have 2 whole groups of 12ths, giving us 24 whole things, or 24 things, plus the 8. 24 plus 8. 24 plus 6 would give me 30. 30 plus 2 gives me 32. Now I can subtract 51 minus 32. If this was 51 minus 31, we'd have what? Exactly 20. Well, we take one more away, so we take one more away from 20. We now have 19. That gives me 19 twelfths. 19 twelfths. So y would equal 19 twelfths. We cannot simplify this, but we could rename it. We could rename it to we have one whole group of 12, and we have 7 left over out of another group of 12. So we could have y equals 19 twelfths or 1 and 7 twelfths. All right, let's take a look at some other examples. Now for these two, I encourage you maybe to pause the video now that you have a better understanding maybe of solving equations with rational numbers. Pausing this and trying to solve number 5. So give that a shot. All right, now we have a minus 4 3/8 is equal to 2 1/2, or 2 1/2. Once again, I'm looking at this left side of the equation. We notice that we have a term here and a term here. This term happens to be a variable. There is no variable of a on the right side of the equation, telling me I'm going to leave this a right here. What I need to do now is get rid of the 4 3/8. I notice that it's being subtracted. I now use the addition property of equality. I'm going to add 4 3/8 to both sides. What that'll do is it'll cancel out the 4 3/8 on the left side, leaving me with nothing here. I'm going to add the 4 3/8 to the right side. We are now left with a on the left side of the equation, which is what we want. Now we have 2 1/2, 2 1/2 plus 4 3/8. First thing I notice is the denominators for these two fractions, these two mixed numbers, are different. We have halves and eighths. I need to ask myself, what is the least common multiple of 2 and 8? Well, if you think about the multiples of 2, it goes 2, 4, 6, and 8. Well, the first multiple of 8 is 8. So there is my least common multiple. It is going to be 8. So I now go over here. The a is still over there. We have eighths here. We have eighths here. The 2 stays the same. The 4 stays the same. The operation is still the same. We are still adding these. And as I stated earlier, the a is still on the left side of the equation. We're trying to find out what a equals. Now, what did you multiply 2 by to get 8? Its other factor is 4. 2 and 4 are factors of 8. 2 times 4 equals 8. So I multiply the numerator by 4. 1 times 4 gives me 4. And that makes sense. 4/8 is the same, is equivalent to 1/2. Now I ask myself, 8, what is the factor times 8? What's the other factor to give me 8? Oh, it's just 1 times 1. Well, this makes sense because I already have eighths, so this is 3/8. Now, remember when adding fractions? Well, in this case, adding mixed numbers. We can add whole number plus whole number. 2 plus 4 gives me 6. Add the numerators. 4 plus 3 gives me 7. Why are we able to do this? Because the denominators are the same, so this stays eighths. So it's 6 and 7/8. And if I wanted to check this, I can substitute in 6 and 7/8 for a. So now we have 6 and 7/8 minus the 4 3/8. Just like when we add or subtract, we have 6 minus 4. Let's do the whole numbers. That's 2. 7 minus 3 is 4. We have 2 and 4/8. But wait a minute, the answer should be 2.5. Oh, I can simplify this by dividing both the numerator and denominator by 4 to get 2 and 1/2. So that is a check. So now I know that my solution of 6 and 7/8 does work. All right, again, feel free to pause the video to attempt to solve this on your own and then check back to see how you did. We have 2/7 times q is equal to 3. All right, now we have a fraction. The previous problems we had addition and subtraction. Now we're doing multiplication. Now we take a look at this. We need to undo this multiplication. We don't want to figure out what 2/7 of q is. We want to know what q is. We know that if we take q and break it up into parts of 7, we have 2 of those. We have 3. Now we're going to undo this multiplication by doing the inverse operator, which is division. So we're going to divide both sides by 2/7. If you want to think about this, really, too, this could help as well. We're going to divide this by 2/7. I might write it like this: divide 3 by 2/7. This is now gone. I have q left is equal to, well, we have 3. And I'm going to write 3 as a fraction to help me visualize this a little bit. 3 divided by 2/7. If you recall in our work from topic 1 where we divided fractions, we understood that we had to multiply by the reciprocal of the second fraction. When you add and subtract, you must have a common denominator. When you multiply and divide fractions, you do not. So this 3/1 stays the same. It is the first fraction. We now multiply by the reciprocal of this. So now we have 7/2, or 7/2. I immediately look at the diagonals and see if I can cross reduce. 3 and 2 have no common factors besides 1. 1 and 7 have no common factors besides 1. I just simply now multiply numerator times numerator, which gives me 21. 1 times 2 is 2. I can leave it like this. I can say q is equal to 21/2 because that cannot be simplified. Or we can say 2 goes into 21 10 times. So if I have 21/2, I have 10 wholes. We still have halves. Well, if I have 10 wholes, I still have something left over. I have that 1. So either one of these answers would be correct. All right. We have 2 more, and they both deal with decimals. We have 12 and 85/100 is equal to x minus 4 and 34/100. First thing I notice is we have 2 terms on the right side of the equation now. We have the x and we have the 4 and 3/4, and they are separated by a subtraction sign. That's why I know there's 2 terms. On the left side of the equation, there's only one term, 12 and 85/100. I notice the x is, this is the only x in the entire equation. We're going to keep this x right here. In order to keep it on the right side, we must isolate it by getting rid of the 4 and 34/100. Well, I see we're subtracting. Well, the addition property of equality says, hey, if I add 4 and 3/4 to both sides, it'll make this equation still balanced. So I'm going to add 4 and 3/4 to both sides. That leaves nothing here. I now have x. Now, remember, when I add fractions, I must line up the decimals. And when I line up the decimals, I also line up the place values. I can put a 0 here to hold the place value in the tens place. Tens, ones, tenths, hundreds. And again, I am adding. So if I were to add these, 5 plus 4, 9. 8 plus 3, 11. Bring down the decimal point, because the decimal point should be to the left of the digit in the tens place, excuse me. We now regroup here. We have 4 plus 2 is 6. 6 plus 1 is 7. We have 17 and 19/100. Again, I can substitute that value back in. For the x, subtract. Make sure that 17 and 19/100 minus 4 and 34/100 is equal to 12 and 85/100. Let's do that real quick. 17 and 19/100 minus 4, line up your decimal point and your place values, and 34/100. Well, let's take a look. 5, this becomes an 11. This would become a 6. 11 minus 3 is 8. Bring down your decimal point. 6 minus 4 is 2. That's 1. Hey, that works out, so that checks. I'm happy. All right, last one. And again, feel free to pause the video. We have 15 and 95 hundredths is equal to 3 and 19 hundredths times n. I have a one term on each side of the equation. There is no addition or subtraction. I don't see any operation sign. All I see is a number right next to a variable. I see this rational number, 3 and 19 hundredths, next to the variable. Hey, that means I am multiplying these. To undo multiplication, the inverse of multiplication is division. Remember, the division property of equality says whatever you do to one side, I do to the other. If I divide one side by 3 and 19 hundredths, I must divide the other side by 3 and 19 hundredths. That cancels out. I'm just left with n. I'm going to go down here and do some work because it's a little more complicated. 15 and 95 hundredths becomes my dividend. That goes on the inside of the division bar. The 3 and 19 hundredths goes on the outside. Next thing I notice, I have decimal points in my divisor. I have to move it over 1 and 2, make this a whole number. That becomes 319. I must mirror that movement in my divider, or my dividend, excuse me. Move it over 1 and 2. So this new fractor, this new problem really becomes, I need to erase this to give myself some space, really becomes 1,519 divided by 319. Now, something I noticed in class, we tend to forget to place a decimal point here, extend this line just in case we need to, place a decimal, and I might just annex some zeros right here. Now we go ahead and do our division. Well, I know 319 will not go into 1. It'll not go into 15. It'll not go into 150. Now we have 319 into 1,519. 1,519. I'm going to attempt to use 4. So let's try 4 times. The reason I'm doing is 3 times 5 gives me exactly 15. That's going to be too big, so I'm going to try 4. Well, 4 times 9 gives me 36. 4 times 1 gives me 4, plus 3 gives me 7, and 4 times 3 gives me 12. I now subtract. That is 3. This becomes an 11, which is 4. That becomes 4, which is 2. My remainder is smaller than my divisor, which I'm okay with. Now, don't forget, annex that 0. Bring that 0 down. Now I ask, how many times will 319 go into 2,430? Might do the same thing. Look at the 24 and ask myself, how many times will 3 go into 24? That's what I'm thinking about. Now I know it gives me 8. So I'm going to take a look here and see that, let's see here. I'm going to go with 8's going to be too big because that gives me exact 24. When I'm multiplying 8 and get some carryover, so I'm going to try a number 1 less. So let's go with 7. 7 times 9 gives me 63. 7 times 1 gives me 7, plus 6 gives me 13. 7 times 3 gives me 21, plus 1 gives me 22. I get 7. That becomes a 12, which gives me 9. This becomes a 1, which gives me 1. Now, I'm going to annex another 0. Annex another 0. Now, I'm going to tell you this problem right now gives you an irrational number. Irrational. Oh, you know what I just realized? I wrote the problem wrong, didn't I? All right, so that gives me a big mistake here. I wrote this problem wrong. My division problem is incorrect. Oh, I just did all that math and I didn't need to. That's okay. It's extra practice. It's really 1,595. There you go, Mr. Giomini. Way to pay attention. Divided by 319. And I just realized that why would they give me a problem that had an irrational, or that just never, it was irrational answer. So we're dealing with rational numbers. I should probably have a rational answer. So let me redo this here. Decimal point. Decimal point. Add some zeros. I'll annex 2 zeros there. Let's try this again. Now, good thing is I already did this math. I'm going to guess this is probably, well, let's see here. Could I do a 5? Let's try a 5. Because it won't go into 3. It won't go into 1. It won't go into 15. It won't go into 159. Let's try 5 here. 5 times 9 gives me 45. 5 times 1 is 5 plus 4 gives me 9. And that gives me 15. All right. Hey, I get n is equal to 5. I can check this by multiplying 3 and 1900ths times 5. Wow, this makes it a lot easier, doesn't it? Let's go with, that gives me 45. That's a 9. That's a 15. Remember, move the decimal over. Let me make that a little neater for us here. Move over once and twice, and there I go. All right, I'm glad I caught that mistake. Again, glad I made the mistake. It shows that we make mistakes. Nothing to get frustrated about, upset about. Just reevaluate what you're doing, look at it, review, and see if you can find your mistake. All right, take care. I hope this helps. Bye-bye.